The graph of a linear equation in two variables is a line. This is lesson 19 for Unit 4. So this lesson is the result of many lessons leading up to this one. In previous lessons, it was stated that there were 4 things that needed to be proved about lines before we could state definitively that the graph of a linear equation in two variables is, in fact, a line. First, we must define a number for each non-vertical line that can be used to measure the steepness or slant of the line. Once defined, this number will be called the slope of a line and is often referred to as the rate of change. The second thing we did, we must show that any 2 points on a non-vertical line can be used to find the slope of the line. The third thing we did, we must show that the line joining 2 points on the graph of a linear equation of the form of y equals mx plus b has a slope of m. And the fourth lesson we did, we must show that there is only one line passing through a given point with a given slope. So now this lesson is the conclusion of all this previous work. So to start off with, do exercises 2 through 8 using graph paper to graph the equations. We are skipping exercise 1, so you don't need to do that one. Continue the video when you are finished. Okay, you should have exercises 2 through 8 completed. I will go through the answers, and if there's any questions, bring them to class. So here is the answer to 2. Concluding 2. Three. And here is 4. And 5. And 6, 7, and 8. All right, so let's take a look at example 1. You're going to write this in your journal, and you need to use graph paper for this. So now that we know that the graph of a linear equation in two variables is a line, and that there is only one line that can pass through 2 points, then we can easily graph equations using intercepts. We already know that the y-intercept is the location on the graph of the line where the line intersects the y-axis. The point of intersection will have coordinates 0, y. Similarly, the x-intercept is the location on the graph of the line where the line intersects the x-axis. The point of the intersection will have coordinates x and 0. To graph using intercepts, simply replace the symbols x and y with 0 one at a time, and then solve. So graph the equation 2x plus 3y equals 9. Replace x with 0 and solve for y to determine the y-intercept. So you should have something that looks like this. And again, you want to make sure you show your work. So the y-intercept is at 0, 3. So now we're going to replace y with 0 and solve for x to determine the x-intercept. So now we have 2x plus 3 times 0 equals 9, and so x ends up being 9 halves. So the x-intercept is at 9 halves and 0. So now that we know the intercepts, we can place those 2 points on the graph and connect them to graph the linear equation 2x plus 3y equals 9. Notice how they've converted. Here is 0, 3, and 9 halves is 4 1/2. So it doesn't matter if you represent this with a decimal or a fraction, it's the same point on the number line. So graphing using intercepts is an efficient way of graphing linear equations that are in standard form. Remember, standard form is ax plus by equals c. Graphing using the slope and y-intercept is the most efficient way of graphing a linear equation that are in the slope-intercept form. Again, that is y equals mx plus b. And creating a table and finding solutions is another way that we learn to graph linear equations. So all three of these methods work, but some methods will save time depending on the form of the equation. For exercises 9 through 11, you're going to use graph paper to graph the equations and then continue the video when finished. All these will be in the standard form, so you'll be using intercepts to graph these equations. All right, you should be done with exercises 9 through 11. Alright, so let's wrap up. We know that to prove the graph of a linear equation is a line, we have to show that any point on the graph of the equation is on the line, and any point on the line is on the graph of the equation. We can use what we know about slope and the fact that there is only one line with a given slope that goes through a given point to prove that the graph of a linear equation is a line. And we have another method for graphing linear equations, and that is using intercepts. All right, we'll see you in class.